Okay, I'm back, and now we want to talk about how the plates interact. So the first kind of interaction is going to be called a divergent zone. So at a divergent zone, the two plates are going to move away from each other. Okay, then as they do this, what's going to happen is material from the asthenosphere is going to rise into the crack. So originally, let's say that you've got a plate over here, and you got a plate over here, and this plate's going this way, and then this plate's going this way, and then underneath it you've got molten material from the asthenosphere is going to come in, and it's going to start to fill in that crack. Okay, then as that crack gets filled in, the temperature goes down, and it turns into solid rock in between those two plates, but there's always more material coming in underneath it. So eventually it's going to crack this rock, and then the two plates are going to move apart a little bit more, and then new material is going to fill in that crack, and then that's going to break. And so that's how we get these stripes that go down the center of these divergent zones. So you get a stripe over here, and you get a stripe of rock on this side, and then another stripe, and then another stripe, and it's all caused by this. It's kind of like a conveyor belt, how these plates are moving apart, and then the crack is being filled with new material that makes new ocean floor. So this is where the ocean floor comes from, is from these spreading zones. And we call this a divergent zone. Now, the divergent zone can also occur underneath a continent. So an example of this would be Africa. So you have the African plate. So let's draw that. So let's pretend here is a solid African plate, but you've got underneath it, you got hot material that's coming up, and it's causing a crack to develop, and then the crack fills in with water, and so you have a whole string of lakes in Africa. So Lake Tanzania, Lake Victoria, and these lakes form a chain that kind of looks like this. And so what that is that's a spreading zone. But the continent still hasn't quite pulled apart down there in southern Africa, but it has in northern Africa. So if you go up to northern Africa, you're going to have the Red Sea goes off like this. So that's where the ground is pulled apart enough that a lot of water has filled it up. So you have the Red Sea, and then it continues north under Israel like that. So that's an area where a continent is in the process of breaking apart. So do you remember that we said that at one time North America and Africa were connected together, but since that time period they have broken apart due to this rifting. Okay, another thing is different types of rocks make up the ocean floor. So that in that picture there, so let's erase this and look at this in a little bit more detail. So we need a bigger version of this spreading center here. So again, here is one plate, and then over here is the other plate. Okay, so you've got material from the asthenosphere, and it's coming up and it's filling in this crack. And so at the surface you're going to have basalt. So that's one type of material that when it cools, it's going to turn into the rock basalt. And it's liquid when it comes up here to the surface. And so what it does is it cools off so quickly, it makes what's referred to as pillow basalts up there at the top. Okay, then you still have some basalt down here. Okay, and then as material comes in, it's going to crack this, And then what you get is a whole series of sheeted dikes and this is going to be another kind of basalt that is going to fill in these cracks. Okay, now what's happening down here is this is yet going to be another kind of material that's going to be called periodontate. It is down in this region down here. So you end up with different layers of the ocean floor. And then this whole thing cracks and is going sideways. So similarly, you're going to have your pillow basalts over here, and then underneath that, you're going to have your sheeted dikes that are going through basalt, and then under here is that periodontate. And then another thing is that as the ocean lithosphere cools, it's going to get thicker because it starts out with this area down here is very, very hot, but as it moves further and further away, it's going to get cooler, and so as it gets cooler, then this area gets thicker. And because it's getting thicker, that means it's getting more dense, and so it starts to kind of drop and get lower topographically. Okay, so now let's talk about how plates collide, and that's going to be called convergent, and we're going to do that in our next segment.